Hello everyone, in today's video we're going to take a look at some examples working with complex numbers. Okay, so here are the numbers we're going to take a look at. For complex numbers we normally use Z instead of X, say X for real numbers. So Z1 is 2 take away I, and Z2 is minus 8 plus 9i. And we're going to take a look at how to represent these on a picture. So we're going to show these numbers on a single Argand diagram. I'll make a few comments about this. Then we'll take a look at finding the modulus. I'll say a few things about what this means. The modulus is Z1, written like that, and the argument, so finding the argument of Z1, and finally let's take a look at finding the quotient, so the result from dividing Z1 by Z2, and I want to write this in the standard form for complex numbers, which is a plus bi, where a and b are real numbers. So there you go, this is the problem we're going to take a look at in this video. Let's start with a, showing the points in the Argand diagram. Okay, so fresh page. Solution. Okay, so the Argand diagram has two axes. The x-axis is the real axis, which we write RE. We write it quite curly, it's quite special. And the y-axis is the imaginary axis. And the coordinates, well, these along the x-axis, they're just real numbers. Just get some x value. And along the y-axis, this is the imaginary part of the complex number, which is b. Okay, so the first number, a plus bi, is 2 take away I. So a is 2, b is minus 1. So this complex number, we go 2 across on the x-axis and 1 down. Okay, I need to check my scale here. The next question is a 9 on the imaginary axis, so I'm going to call these 2. Okay, so minus 1 is right here. So if I just put the 2 above, it sits by here. This is my complex number Z1. Z2 is minus 8 plus 9i. Okay, so a is minus 8, b is 9. So I have a minus 2, minus 4, minus 6, minus 8, and I want to go 9 up, so that sits here. Here's my Z2. Again, you can use little dotted lines just to help you. For this one, do the same. And this is our Argand diagram. Okay, so this works for any complex number a plus bi, where a sits on the x-axis and the b on the y-axis. Okay, so that deals with part A. Let's move on to part B. So part B says find the what is this? The modulus of Z1. Okay, so modulus, this is just the distance. It's the distance from the origin to our point Z1. Okay, so for all these problems, I would highly recommend a picture. So here is my real axis, here is my imaginary axis, and Z1 is 2 across, 1 down. It's here. So the modulus of Z1 is just this distance. Let's do that a bit better. It is that distance there. And the method that we always use for these is Pythagoras. We always have a right angle triangle. In our case, this distance is 1. The negative just means go down. And this distance is 2. Positive, just go from left to right. So the modulus, using Pythagoras, is the square root of 1 squared plus 2 squared. The modulus of Z1 is equal to the square root of 5. Okay, so that answers part B. Just before we go on to part C, let me say a few more things. Oops. In general, if you have a complex number a plus bi, I would recommend a picture, but for this one it turns out it's quite nice. The modulus is always the square root of a squared plus b squared, something just to keep in mind. Okay, so part C next. Part C says find the argument of Z1. Okay, so what does argument mean? Well, the argument is the angle. And we need to be careful, we can't just say angle. It is the angle made from the positive x-axis to the point, and this angle has to be between, if we're using radians, minus pi and pi. Okay, so let's jump into our example. Our point is 2 minus I. So here, this is our real axis. Oops. Our real axis, this is our imaginary axis. So where's the angle? Well, we cannot go along the top because we're restricted to pi degrees, pi radians. So we wouldn't reach our point, so we cannot use that. So actually we need to go along the bottom. So if we start here, this is our argument. Okay, we're going to have to use a negative, and it's going to be negative this angle. So the best way to set these up, from my experience, is as follows, is to say that the argument is equal to the negative value of this theta, and keep the theta positive in the drawing, just to avoid confusion. Just think about it as some angle. You take some protractor, you're going to build an angle. Think about it as always being non-negative, but when we write the answer, we add the negative. Okay, so in our situation, we got a right angle triangle with sides 1 and 2. These are the opposite and the adjacent. So tan of this angle is the opposite divided by the adjacent, so 1 divided by 2. So the angle is tan inverse of a half. Okay, so you can just pop it into the calculator, remembering to use radians. This will give 0.46 radians. So the answer, the argument, is minus 0.46 radians. And there you go. That is how you calculate the argument of some complex number. And this process, very similar if you take different complex numbers. Very, very similar process, taking care of the possible range of values, always using a positive value for the angle in your picture, and then remembering to change it if necessary in your final answer. Okay, one more thing left to do, a little bit of division. This is part D. So let's get a clean page. Part D, we want to find the complex number that you get from dividing Z2 by Z1. Okay, so the process for this is always the same. We want to remove the I in the bottom of the fraction, and to do that we need to multiply the top and bottom by the conjugate of the complex number on the bottom. So conjugate just means change the sign of the number in front of I. So minus 1 will become plus 1. And if we multiply out, then on the top, okay, we have minus 8 times minus 2, minus 8 times I, then move across to the 9I, we get 18I plus 9I squared. On the bottom, we have 2 times 2, 2I minus 2I minus I squared. Okay, so collect everything together, and remembering I squared is minus 1. So here we can see this is 10I. This I squared is minus 1, so this is minus 9. So minus 9, take away 16, minus 25. The bottom, those i's cancel. I squared is minus 1 here. So minus minus 1 is plus 1. Add on the 4 gives 5. And we want to write this as a plus bi. So write them as two fractions. And actually the numbers turn out quite nice. We end up with minus 5 plus 2i. And there you go. That is how you divide two complex numbers. And the process is always the same. You look at what's on the bottom and times the top and bottom by that conjugate. Okay, so there you go. That completes our question.